computer. All right, so 821. Let's say we have, sorry, get my pen back. Yay, I think it works. Let's say we have 2 points, right? We have 2 points and we want to find the curve that goes through those 2 points, right? This is called curve fitting. It's somewhere on here. It says curve fitting. So we have 2 points. We have some XY and we have another XY, some numbers right in here. And we want to find the curve that fits through that 2 points. So that's what we're doing today for 821. Okay, so for 92, we're going to start there. Mitchell was helping his friend work on his algebra homework. They were trying to write the equation of the line that passes through the points 515 and 37. Suddenly, Mitchell had an idea about finding linear equations. Look, he exclaimed, we know that the line can be written in the form y equals mx plus b. And we also know that the points 515 and 37 have to make the equation true. So we can substitute in these 2 points to create a system of equations. When we solve that, we'll know the values of m and b and we'll have our equation. What is Mitchell talking about? Use his method to write the equation of the line that goes through to these 2 points. Will Mitchell's method work to write an equation of a line through any 2 points? Okay, hold on one second. Okay, so if we wanted to find the equation that goes through these 2 points, so let's write them down, 5, 15, and 37. If I did like a little sketch of this, 5, 15, 3, 7, just a rough sketch. Let's say 3 is here, 7's here. So that's my first point. Second point is 5, 15. So a little bit over, and 15 is a little bit higher than 7, like twice as high. So the other point's here. And we want to make a line through these 2 points, right? We want to find the equation of the line that goes through those 2 points. The y equals mx plus b. We could do that, right? Because we have a slope formula. Our slope formula is m equals, this is good review for the CASP, or what used to be called the STAR test if we're going to take it. I don't know. That's still up in the air. They might have you guys take it. I don't know. y2 minus y1 over x2 minus x1. Okay, so we could find the slope. So I do 7 minus 15 over 3 minus 5. Right, and I get negative 8 over negative 2, negative divided by negative is positive, so the slope is 4. Okay, the slope of this line is 4. That looks accurate because it's going up. Okay, then I could find the b next. I could plug in one of these points and find the b. Okay, we could do it. Great. Yes, we could definitely do this. Okay, I could continue, but that's all I want to do for this problem because I want to get to the curve part. What if I want to find a curve through these 2 points? Okay, so I'm going to clear this out and move it to the next screen. Take a second if you need to copy anything down. Okay, let's go to the next screen. Here we go. Use Mitchell's method from problem 92 to write the equation of the line that passes through the points 2, 3, and 5, negative 6. Mitchell thought that maybe this method from 92 could be used to write equations of exponential functions. Mitchell wondered if he could write the equation of the exponential function that passes through the 2 points 244 and 6, 729. What is the general form of an exponential function that has an asymptote? Okay, so let's try and find the equation that goes through these 2 points. Okay, so we almost got there. So for 93, just put C92. I'm going to skip that for now. Okay, so C92 for 93. Okay. For 94, we are going to do this part here. So here are our 2 points that we have. We have 2, 144 and 6, 729, 6, 729. These are really big numbers, huh? So basically we're telling you 2 points on the curve, right? We don't know what 0 is. We don't know what 1 is. 0 is really important. That'd be nice if we knew that, but we don't. We know 2 is 144. We don't know 3, 4, 5, but we do know the 6th term is 729, right? Our goal is to find the multiplier. Like we have to multiply once, twice, 3 times. 1, 2, 3, 4 times. We have to multiply 1, 2, 3, 4 times. The multiplier 4 times. So I need to draw another thing in here to get to 729. Okay, so how do we find what the multiplier is? Okay, do you guys remember the equation for exponential function? What is the equation for exponential function? What is our basic equation? You guys there? $14 people. Okay. Our basic equation is y equals a times b to the x power, right? Where a is our starting value. You're gonna need this for the quiz today. So this is good review for the quiz too. B is our multiplier. Okay, we have 4 multiplications here. Well, how do I find the b value? Okay, first we want to find the b value since we have this table. Well, so basically we have y6, right? To find the multiple, I have y6 and I have y2. And we want to divide those two things, y6 divided by y2. Okay, we want to take the one that's after and divide it by the one before. So 729 divided by 144. But that's not going to be our multiplier. We have to take the root of how many there are. From 6 minus 2 is equal to 4. So we have to take the 4th root of this, okay, and find this number. I got to grab my calculator real quick, so I'm going to go do that, and I'll be right back, and you can grab yours if you don't have yours. Okay, so how do you do 4th root in your calculator? Well, first you type 4, then you press the second exponent button. Okay, and then you'll have to put parentheses, 729 divided by 144, end parentheses. So again, how you do that is, since I'm taking the 4th root, I'm going to type in the number 4. I'm going to press the second button. Then I'm going to press the exponent button, and it should give you like a symbol like that in your calculator. Okay, or it'll say, actually, your calculator might look like that, which means that that X is a 4th root. Okay, and then you're also going to have to put parentheses in because we're taking the root of this whole thing. So parentheses, make sure you put parentheses, 729 divided by 144. And see what you get. And let's see, what do we get when we do that? I got that in my calculator. Okay, my calculator, I actually have a nicer calculator today. Gives me 3 halves. Hopefully it doesn't give you 1.5, even though that's what it's equal to. You know, this tells us the growth rate, right? So our multiplier is 3 halves or 1.5. So we know what the B value is, it's 3 halves. We don't know what the A value is here. And we know it's to the X power, right? So this problem is growing. The numbers are getting larger. So if I want to find the A value, there's 2 things I can do. I could plug in a point for X and Y, like I could plug in, let's say this point, and then I could solve for A, or I can use the multiplier and go backwards. So let's say I multiply by 1.5, multiply by 1.5, multiply by 1.5. Now let me go backwards and divide. So I could take 144 and divide by 1.5 twice, right? So 144 divided by 1.5 is 'So when I do that 144 divided by 1.5, I get 96, right? So that tells me that this term, the first term, is 96. But now I need to do 1.5 again. So I do 96 divided by 1.5. Divided by 1.5, and that gives me 64. So that tells me, hey, the 0 term is 64. So this number right here is 64. Let me erase the A right there, and I'll write in 64. 64. Okay. Okay, so let's see. So our equation, that's our equation right there. Y equals 64 times 3/2 to the x power. If you want to change that to 1.5, you can. That's like probably a little easier for you guys. 64 times 1.5. That tells us it's growth because our b value is greater than 1, right? So there we go. That is how you find the equation through 2 points, okay? So using your values for a and b, write the equation, the function that goes through the 2 points. There it is. I could test this out by plugging in a value in here. Let me erase some of this, and I'm going to plug in like 6 and make sure I get 729, because you always want to test your equation to make sure it's right. So I need to go to, so I'm going to plug in 6 in here, right? And I should get 729. So y equals 64 times 1.5 to the 6th power. Okay, put this in your calculator and see what you get. 64 times 1.5 to the 6th power is 729. So I got 729. So that tells me, hey, my equation is working. My function is working because I plugged in a value and I got the value I'm supposed to get. If I plug in 2, I should get 144. If I plug in 1, I should get 96, and so on and so forth. Okay, so let me clear this away. I got to clear the screen away and see if we've got anything for 95, what 95 says. So clear 95. Okay, write the equation of an exponential function that passes through the pair of points. Okay, so here's some more examples. So let's do one more example, maybe 2. Let's see. This bar is always in my way where I need it to be. Okay, so here's this is our x1, y1, and x2, y2, you know, these are 2 points, right? I like to make a table. If you haven't copied down these points, go ahead and copy them down. -1, -2, and 3, -162. Those are our 2 points, right? So -1, -2, you know, if I do a little sketch here, these are in the negatives too, so, and +3. So -1 is over here and it's like at -2. So that's one of the points, right? 3, 1, 2, 3, and then -162 is like way down here, right? So I'm going to put a dot like down here. So this curve, is it growing or is it decreasing, guys? You guys there? -1, -2. I don't know the 0 term. I don't know the first. I don't know the second term. I do know the third term is -162. This function is decreasing because it's going lower and lower and lower, okay? So that tells me something about my b value since it's decreasing, right? What do I know about b since it's getting smaller and smaller and smaller? B has to be less than 1, but greater than 0. That's how you get a decay problem, right? So let's find what b is, okay? Use our method from before. So I have the third term, so I want to find b. I have the third term and the first term. So I'm going to take the one that's later, the third one, and divide it by the -1 term. Okay, so you have to divide these two. So you take the one that's after and divide it by the one that's before, and then you have to take the root of how many there are from that. So I can count 1, 2, 3, 4. So again, I'm going to take the 4th root. Is it always going to be a 4th root? No, but this problem just happened to be that way. Hopefully maybe the next one's not the 4th. I think this one is the 4th root too. These are 4 apart. So it's not always the 4th root, but for this problem, sometimes you can take the 3rd root, right? If they're 3 apart, you can take the 3rd root. Like if they would have given me this one, I would have taken the 3rd. If they would have given me that one and that one, then I would take the 3rd root. If they would have given me this one and this one, these two, then I would take the square root. And if they would have given me this one and the one above it, the two that are right next to each other, then I wouldn't take any root. I would just do y0 divided by y negative 1, then I wouldn't have to take any root. That would give me my multiplier. Okay, so I hope that clarifies that. All right, I want to erase this. I got pretty crazy here. Okay, so we're taking the fourth root because they're 4 apart from each other. So I want to divide negative 162, and we keep the negative in there, divided by negative 2. Okay, and this is just 81. Don't need a calculator for that. Fourth root of 81 is 3, because 3 to the fourth is 81, right? 3 times 3 times 3 times, that's 81, because this is 9, that's 9. So the fourth root of 81 is 3. I don't need a calculator for that. So that tells me, hey, my equation is 3 to the x times some a value equals y. So now we have to find what the a value is, right? Which is kind of easy because they give us the negative 1 value. So I just need to go 1 value up. So I need to multiply by the multiplier, which is 3. Okay, so if I multiply negative 2 times 3, well, that's negative 6. Let's keep going. What's negative 6 times 3? Negative 18. What's negative 18 times 3? So 48. 18 times 3 is, no, it's 54. So negative 54. And then check, multiply 54 times 3. Negative 54 times 3 is negative 162. So this tells me, yeah, the multiplier is 3. Okay, and we got the correct multiplier because I got to negative 162. So since my 0 value is negative 6, that's my a value. So this is negative 6. Can you have a negative a value? Absolutely. We just got one. Okay, so that is how you solve that equation. Should we do the last one right here? What time do we have? Hold on one second. Let me check the time. Okay, 10:33. So let's see. Let me move this out of the way. Okay, let me erase some stuff. Yeah, let's do the last one. Let's do one more example, even though it's going to be a fourth root, and I wish it was a different root. Let's go for this color. Okay. So for B, let's try B. 2, 1.75. Ooh, we got a decimal. And negative 2, 28. Okay, which one comes first? This one, right? Negative 2, 28. And then negative 1, 0, 1, 2. See how it's important to make the table. Okay, so 2, 1.75 here. All right, how many are we going up? 1, 2, 3, 4. And I can know that by doing 2 minus negative 2, like that. I could take this one and subtract that one, right? And then I would get 4. So that tells me I'm going to take the fourth root because they're 4 away. They're 4 numbers away from each other. So I'm going to take the fourth root. If it was just this one and this one, that would be then I would take the third root, right? Once I find the multiplier. Are the numbers getting bigger or smaller? From 28 to 1.75, is that getting bigger or smaller?
Smaller.
Yay, yes, it's getting smaller. So that tells me that the B value is less than 1, right? But greater than 0, because that tells me my curve is going to be going down, 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 right? It's decreasing because the numbers are getting smaller. So again, which one am I? So you're just going to divide. All this is dividing. To find the multiplier, you're going to divide. Am I going to take 28 guys and divide it by 1.75? Or am I going to take 1.75 and divide it by 28? What am I going to do? Take a guess. You take the one that's after, right? So the 1.75, and you divide it by 28, okay? And then you're going to take the fourth root of that. So again, in your calculator, I can do this all at once. I'm going to type in 4, then I'm going to type in the second function, and then I'm going to type in the exponent, because right above the exponent should be a little X, it should be a button that looks like this, X root. And so you're telling the calculator you want it to take the fourth root. If you want to take the third root, you press 3 second exponent button and it'll make the third root, okay? So when I do this in my calculator, 4 second exponent of parentheses, don't forget the parentheses. So I want to do a parentheses after I type this and do 1.75 divided by 28. And that gives me 0.5 or a half, right? 0.5 or 1/2. So we did get a number that was less than 1. That's good because I knew this was decaying and it needed to be less than 1. So my multiplier is 0.5 to the x power. My a value, I need to find what the a value is here. So y equals some a value times 0.5 to the x power. So the a value is the 0 term, right? So we want to find the 0 term. So I could either go forward and multiply by a half. That's pretty easy. Multiplying by half is easy. So I like that method. So 28 times a half is 14. 14 times a half is 7. 7 times a half is 3.5. And then 3.5 times a half should be 1.75. But we care about the 0 term, right? That's your starting value. So that means my starting value is 7, and that is the equation right here. So I can test this equation, right, by plugging in any number I want. Let's do this one. Let's plug in 2, and I should get 1.75. So y equals 7 times, I'm going to put a half to the second power. It's pretty easy to do without a calculator because a half squared, 1/2 times 1/2 is 1/4. And then 1/4 times 7 is 7/4. And I'm just going to put 7 divided by 4 in my calculator. And I get 1.75. Yay, I got 1.75, which is what I wanted to get when I plugged in 2. I should get 1.75. All right, guys. So that is the lesson for today. I'm going to clear these drawings. So if you need to copy anything down, please do. And we have the moment of truth here. Thank you for those of you who have stuck around. There's only 12 for third period. I'm sure there will be more for fourth period. We just have one more thing to do. People who don't take the test, anybody who bailed and didn't take the test right now, they're going to have to take it when we get back. And it's going to be a different version too. So maybe a harder version. That would serve people right? So let me stop share here. And then, so, let me stop.